Sustainable product design is what I'm here to talk to today, in theme with all of the other presentations that have taken place so far, hopefully. First of all, a little bit about me. Some people in the room know me from my magazine work over the years. For those who don't, a little bit of tiny background. So I started my career as a fisherman in the North Sea fishing fleet. Why am I telling you that? It seems pointless, but there's a bonus slide at the end which explains all. I then studied 3D product design, became an engineer, worked in automation, high-speed robotics. I worked at Sellafield, ICI, Metal Box, Coca-Cola Schweppes, places like that. So I've done a bit of engineering, so I know a little bit about how things get made and used. 30 years in the magazine industry, editing mechanical, electrical, electronic magazines over that period, and still doing that now. More recently, and this will become clear, I've started to move into the area of sustainable product design. Recently finished a certificate in product life cycle assessment, so I've got a reasonably good understanding now of how to measure the environmental impact of products manufactured. Currently studying with the University of Cambridge on trade sustainability and law, so looking about how products are moving across borders, that type of thing. But most importantly of all for this presentation is once a month I volunteer at a repair cafe where people bring broken things, and there's a room full of people with toolkits and the best intentions, and we try to fix stuff. So it gives us a real insight into how products are designed, used, how they fail, whether they can be repaired, etc. So why am I here today? So 18 months ago, I have a software business, and we went for a net zero assessment at the University of Kent. While I was there, I bumped into a guy called Tony Duke from Duke Voyagers Shipyard, and these guys are working on the design and manufacture of a net zero yacht. And I was fascinated by that idea. I thought, how do you design bill of materials and build a net zero yacht? So 3 of us went on a 12-month sort of tour of discovery, 25 engineering exhibitions throughout the UK, seminars, etc. And we did 1,000 interviews with suppliers of technology, design engineers, R&D engineers, etc. to try and find out who was doing what in the world of sustainable product design. And the good news is pretty much everyone was doing something. They were doing different things at different pulse rates, at different frequencies, etc. But everyone was doing something. So then we thought we'd better start saving all that information and sharing it. So my software development team built what we think is the lowest carbon footprint publishing platform, which we're about to release. Then we thought, let's see if we can share it with a wider community. So we've partnered with the IET to develop guidelines for sustainable product design. The blueprint for that is on their website. You can take a look at that. You can see what we're trying to achieve, and you can get involved in that project by commenting back to the IET. And then I find myself here today, proud to be invited by NCAB to talk to you. So on our travels, we encountered this graph. It's all about greenhouse gases. It's called Scope 1, Scope 2 and Scope 3. It's about where greenhouse gases are generated and what companies can do to mitigate them. So if you're an OEM and you are designing a product, you're going to need to know a little bit about the technology that's involved in your product and also how it's used. So when we were conducting our interviews, we started to work out what the incentives are to design and manufacture sustainable products. And we've got 14. I'm not going to go through each of these in detail. You can take a photo of the screen, or I can send people a presentation afterwards if you'd like to. I'm just going to focus a little bit on the legislation. CSRD, Corporate Sustainability Reporting Directive. Now remember that, it might come in important a little later. Product passports, so there's legislative pressure. Consumer demand, consumers are spending more money on sustainable products, believe it or not. Taxation, something called the Carbon Border Adjustment Mechanism. High carbon materials are going to start to be taxed at the border, starting with steel, aluminium, fertiliser, cement, that type of thing. Education and employment, recruitment and retention, much easier if your brand is working towards a more sustainable future rather than against. Then what we encountered was something called the 10 R's of sustainability. There are different versions of this according to which industry you're in. This is a good one for engineering. There's a modified version for food and drink, modified version for fashion, that type of thing. This is a kind of overall strategy that a company can deploy to start moving towards a more sustainable future. So you've got a strategy there, but the problem is, how do you deploy that? What tactics do you need? We ended up going through our research, and we ended up with 18 pillars of sustainable product design. And again, I'm not going to go through all of these, but I'll highlight a few. Functional efficiency, an interesting one. I was talking to Jan about this. We were at the Advanced Materials show a few weeks ago, and they were talking there about graphene-based tracks on PCBs for more efficiency in terms of electrical and thermal conductivity. But the really interesting area, and this is where the stuff from Jiva and ART comes in, is design for disassembly, maintainability, repairability, and upgradability. So if you want a durable product that lasts for a long time, you need to address these areas, and these areas are often overlooked during the design process, which is more focused on design for assembly than disassembly. So is this actually happening? Is there anything is this just a talking point, or is it real? Well, what you see here is interesting. This is the French Repairability Index. I don't know, hands up anyone in the room who's encountered the French Repairability Index. No, I don't see any. I didn't think I would. So on products in France, the idea is, so domestic appliances, there will be a repairability index based on this chart, just letting you know that when your washing machine breaks, what is the probability it can be repaired and put back into use? Design engineers haven't really had to encounter that before in a consumer market, and it's looking for documentation. Is there any documentation to explain how to repair it? What tools are required? Do you need specialist tools, or can you just do it with a screwdriver and a spanner? Can you get the spare parts you need, and how much do the spare parts cost? All things that are pretty new to the world of consumer electronic sales. Is it really happening? So I've got 3D printer cells that I use. I'm a maker, I still design and make stuff. One of my printers is a Prusa A3, and going back to the legislation, there's something called ESPR, Eco Design for Sustainable Product Regulations, and that covers something called product passporting, or digital product passporting. And this is the first one. I've come across, and it just happens to be a machine I own. So this is a product passport, and it states the company's commitment to circular economy and sustainability. It shows you where the components were manufactured and where they've had to be delivered from to their manufacturing facility. So you can see there 54 from EU, 13 from USA and other countries, and 33% from China. Then it provides you with maintenance, repairability, and spare parts information. So everything you need to know to keep this machine alive, they provide to you, including all the spare parts. All the plastic parts, interestingly, they don't sell you the plastic parts, they sell you the CAD file, and you then use the machine to manufacture the parts themselves. So if it's a repair or an upgrade, it is literally repairing or upgrading itself. It also identifies all the material types in all of the components, so that if the machine at end of life is disassembled, you know what to do with those parts, where they can and can't be recycled. Interestingly, I did notice that the electrical components up there aren't broken down into as much detail for obvious reasons, because they are assemblies of different parts. And I would hope over time that more effort will be applied there, I guess, with things like soluble circuit boards, etc. Then, this is the interesting one. There is a community based around the Prusa printers, and what's happened is the company has asked that community for ideas for all of the things you can do with the components of an end-of-life printer. That's proper circular economy stuff. So there's an Arduino robot arm and a motorised camera slider. So you can just ask people to help, and they do. So right at the beginning, I was saying that I was a fisherman, which I was when I started when I was 16. And fishing nets are quite tricky things. A trawl net will last for about a year. and then it needs to be, needs to be disposed of effectively. Too many of them were disposed basically in the sea. That doesn't happen anymore because the latest filament that I'm buying for my 3D printer is called OrCA. It's a nylon PA6 with carbon fibre reinforcements. That's a pretty serious bit of engineering polymer, and it's manufactured from old fishing nets, because there's an infrastructure in the UK that collects old fishing nets now and turns them into high valuable polymer materials. You can get injection moulded options. Some of it's used to manufacture components for trainers and shoes. Another company, I think based in the US, is manufacturing sunglasses, etc., etc. Because these are good quality materials. It's nylon, polypropylene, high density polyethylene, etc. And there is an infrastructure for this. And I think that really needs to be emphasised. So then the most controversial slide. Who's going to do all this work? Because there's quite a lot of work to do. Well, this is the demographic profile of different regions of the world. And if you look here, that's the 1950s, that shape there, and this is 2100. That's a young workforce, that's an older workforce. So the goal at the moment really is to retain all of the skills you've got, retain all of the experience amongst your workforce. Make sure that that experience is passed down. Make sure it's part of a process of training, ART, upskilling, reskilling, new skilling, and moving into a more electrified world. If you think about some of the new skilling, if you've been designing internal combustion engines and mechanical gearboxes for the last 20 or 30 years, you may need to become a high voltage electrical engineer sometime pretty soon. So there's going to be a whole lot of re-education amongst the engineering workforce. So what are we doing? Sustainable engineering project. We decided to build a spreadsheet effectively with a digital magazine alongside, and we want to record all of the components, technologies, services, materials, etc. that can contribute to a more sustainable design process. This platform is going to be launching over the next few days. It's like right now, and there's an opportunity for any engineering company to register an account and start throwing ideas into this. It can be just an idea, it can be a product, it can be research, it can be prototype, it can be a case study. We just want to hear from everyone involved in the engineering sector about how they think they could help progress sustainable product design. And we hope this will grow out quite swiftly. We'll get 1,000 technologies in there before we know it, it's the plan, and then we'll race on to 10,000, and then that will be the world's largest database of this type of technology. And that's it. That's me. That's sustainable product design. If anyone wants to talk to me online, that's my LinkedIn QR code. I can talk to you about in much more detail about legislation if anyone's interested. There's a whole bunch of that heading the manufacturing sector's way soon.
Amazing.
Thank you.